All right, we're back. After a kerfuffle of weirdness with trying to get the console to clear, of course it doesn't clear on the Eclipse IDE. We're COMP228, and it's week 4, lesson 4, part 3, and we're continuing with this, deeper look at methods and objects, right? And remember what we said when we were going through the PowerPoints before. When I look at the PowerPoints, I always talk about not reading them because there's some good information in here, but remember they give us some examples in the PowerPoints about how to use methods, to call methods from within methods, and so on. Excuse me. It's the same kind of stuff that we've talked about before, but in different languages, like in C#. It's just what we're looking at here is the differences, the nuances between C# and Java. And that's where we're making the comparison, because primarily we learned C# at Centennial first. Okay, we're going to continue on with this kind of stuff. We talked about this actually. We talked about controlling access members and different ways of doing that. We talked about referring it with the this reference. We've been using the this reference from day 1, right? From the first moment we got together in Java, we've been using this reference. So that's one way we've been doing it, right? And I use the this reference a lot to differentiate between local variables and instance variables that are part of our class, right? So it's a good practice to do that. Next, you can also use the this keyword to work with members or methods of the class. So if it's a method that's private, or if it's a method that you want to call, you don't have to use, just if you want to be explicit, you can use the this keyword to call that method, right? So going back to our Eclipse example, right now in our program, we can't do it because we're accessing a static member, right? Static members can't be used. You can't use the this keyword for that. But if I was going to create a method, which I do have one called toString, which I've called. If I want to call that when we launched the person class for the very first time, I could use this keyword by putting this. Say this dot toString, right? And it's exactly like if I was just to call the toString method, right? So this is a good way when we use the this keyword. It's a good way for us to explicitly call an object, and we can differentiate between objects that are local or ones that are part of our class, methods and instance variables, if you will. Okay, let's continue. So we've kind of covered this to death. Actually, we've been using this, like I said, from day 1. So I'm going to kind of skip over this section. Overloaded constructors. When we can have more than one constructor for a class. We talked about this before in C#. We covered it in COMP228, where right now we have the person class, and I have my empty constructor, but I want to have another constructor for my person class, right, that enters the age. So let's do that. How do I do that? I create another signature, and you do one of these. Say signature, and I enter in a value, an integer value this time for age. Right, so I say integer age, right? And what I'm going to do is I'm going to say, well, this dot underscore age, then directly access is equal to age. That's not an uncommon way of doing things. So this is the, constructor that allows that sets age, right? There's empty constructor and a constructor that sets age. And you can make as many of these constructors as you like. But what happens if you have a question for you? And let's see if you guys know the answer, right? Or maybe Ravina knows, because she seems to be on me for different things, right? What if I have a constructor that I have different parameter names? So I have, but they're the same type. So example would be this: I have person int age, and I have person int something else. Can I do that? Why not? Why can't I have that?
Then it's the same thing.
Well, look, here's my. I have an age instance variable, and let's say I also want to know the person's weight, right? So I'll say int underscore weight, another property of the person, right? So a person has some weight, he has an age, and you know what? I want to make another constructor here, constructor that sets weight, right? And the only way you can do it is through the constructor, person int weight, and like that. And I can say something like this: this dot underscore weight is equal to weight. How come I'm getting an error?
Because it's the same constructor.
A different constructor. I don't know what you're talking about. It looks different to me. I got it. I got.
Anyways, constructor is type of method. So all the rules that apply to the method apply to the constructor as well. So
All the same rules that apply. That's a good answer. All the same rules that apply to methods apply to constructors. Is it the same in C#? Can you enter different? Can you enter the same? Two integers. Can I ask for 2 integers, or is it the same? Or can I do that in C#? No. This is a very common mistake that people make. They say, "Well, I'm entering my age, but I want to enter my weight too. My weight is it's an integer, so that should be okay. But what if my weight was a float? So I change this to float. My weight is a float now, and now I'm going to add in a float value instead of my. That would work, right? Because now what's happening is it looks to see if there is. It's got to be different types. Otherwise, you can't declare another signature, right? So signature, when we say the signature of the constructor, whether it's a method or a constructor, it's the same thing. It has to have different types. If you have the same types in the same order, even, it'll mess up. It won't allow you. It won't know what to do. What happens also if I have 2 different constructors, right? And I enter something else that's in between an integer and a float. Like for example, I have a float weight, right? But I can also ask for a double, something like this, right? So let's say we have a float that's a weight, and then somehow we'll make it so that my IQ, right? IQ is a double, right? Because double precision. I'm crazy smart, right? Just saying, right? I'm making it up. Come on, guys, making it more interesting, right? Okay, so here's my person. Let's say I have a double, and it's my IQ. And then what I want to do is I want to go this dot IQ. Here it is, my double. Wait, what happened? Oh man, I did the wrong thing. I meant to do double and then underscore IQ, not the other way around. All right, this I can do. So double this dot underscore IQ is equal to IQ. I can do that. But what if float and the double are very similar, right? How does it know that I'm entering a float or a double when I enter in a literal, right? So I want to pass it a value. So this is my constructor that sets IQ, right? And let's just put another little thing here. I'll say system.out.println. I'll call weight, and we'll say plus the weight value, this dot underscore weight. Why not? And we'll do the same thing for IQ, right? System.out.println IQ plus this dot underscore IQ. Okay, so I want to enter a literal here, and what's the test? Here's a litmus test here for you guys to see how good you are, right? Both values, double and float, are decimal type values, right? They've got a decimal in there. So if I entered a literal and I don't mention what it is, right? What does it default to? Double. Okay. So this won't fire unless I put a F next to it, right? What I mean by that is this: if I go to my program Java, and in my constructor, when I create my person class, right, I want to send in a literal value. Like for example, 1.0, right? Which of these will fire? Double, let's see. IQ, double, right? And let's say if I put in 1.0F, right, then it should be the float, yeah? Right, see how it changes? That's how it can differentiate, even though it's a decimal. That's why we have these notations here, F and M, and so on, right? Because what we want to do is we want to try and avoid confusion when we pass literals into methods and constructors, right? So we can differentiate between a float and a double. Yeah.
When it's received as a user input, how do you even?
That's the challenge. Well, no, but you're going to convert it. You're going to convert it. If you ask as a user input, if you enter it in, right? What if I don't have a method that takes a double or a float, but I have a double? Will it convert? Let's look at that one. So here, I'm just going to erase this method. So I'm entering a float value to your take here. So here's my float. I don't have a float. I'm going to put in. I'm just going to comment this whole thing out. So here we go. Comment this out. I don't have a floating point option anymore, right? I only have a double, but I'm entering a float, right? Takes it. It's not airing out, right? Let's see what happens. Still does a double. So it converts my float to a double. It upconverts or casts my float into a double, right? That's what it does. So that's what would happen. If we didn't have an option, if someone put in like a floating point number, and we don't have that option. What about if it was an int? Can I do that? Would it convert? Remember the sequence of casting that we talked about before? A double is a bigger container than a float, right? If I put the other way around, right? Let's do the other way around, right? So here's my I don't have a float anymore, or double. I mean, I have a float. Let's get rid of my double. So you have to be very careful about how that's done because it messes you up in terms of your input and output. Okay, let's try this out. It converts it, right? But it's not converting anywhere because this is already a float. What if I do this? It gives me an error. See, converting up to a bigger container, no problem. Converting down to a smaller container, problem. And it won't do it. If I go to an int, it'll give me an error. If I go to a double, it's fine. And an example of that would be this. If I went back to this, right, and I didn't have an integer, so I don't have an integer age, right? Kill this one for a second. And I go back here to this one, and I run it now. But I take away it's not 1.0, I make it 1. I'll take it. Now, Ravina, tell me which one it will go to, since you're so smart, right? I'm passing in an integer value, 1. But I don't have a constructor that takes an integer, right? Which one is it going to go? Float or double? Float? Oh, we got to make a survey. Oh, we're making a survey now. That's it. Polleverywhere.com. Doing the survey. Let's add a new survey, create a poll. So, integer converts to first. Float? Say float or double? First. Double. Converts first to automatic. Come out. Integer automatically converts first to what? Okay, and we'll say create. Hey, you can join me on. If you want to be anonymous and instead of saying what it is, right? We'll make it a. We'll make it so it's an anonymous poll. You can send your poll to pollev.com/learn for you guys to see what it is, or you can text learn if you're a texter to 37607, and you can choose A or B. A for float, B to double. which one will it go? So float. A double, float. It's pretty big. I got 67%. That means like one person said double and 2 people said float right now. Come on. I need a couple more people answering this thing. Oh, there we go. 3 people said float and 1 person said double, right? So there's 4 people answered so far. So you're saying it's float, right? For the majority. I'm not going to take too long on the silly poll that we're doing, so I'm going to stop it for a second. Go back. Let's see the answer. So kill this one and go back to here and run it and see what happens. So what I'm doing is I'm saying this. I'm saying I'm taking my age. Here's my program. I'm setting in 1, and it's converting it to weight 1.0, and weight, right, is a float and not a double. Why? Why is it going to the float first and not going to the double? Because it's on the way up. It's the closest type up. I remember that's how we talked about casting last week. That's what it does. When you cast upwards, you're going to go to the next biggest container, right? So you're going to go from int, and there's long. If it's not, there's no long, it's going to go to float, and if there's no float, it's going to go to double, right? And if I could do that by just taking this away, if I took away my float and I put it in, it would go to double. It would accept it, right? So that's why signatures are neat, but they're also kind of dangerous, right? Because we have only one value, but there's different types, and 2 of them are very similar, float and a double. I can also put an int and a long, right? And that's what we'd take it next if I had some kind of long value. Okay, let's go back to the PowerPoint. So that's what overloaded constructor means. Overloaded constructor is just like a method with a different signature. Okay, I'm not going to go into too much detail here.
So that overloading, if you have multiple parameters for the methods, and you change the positions, like the order. Again,
that's a problem, right? Because what'll happen is it'll try and figure out if you confuse the compiler. If you try and confuse the compiler, it's bad. It's bad. Don't try and confuse the compiler. First of all, you have to think to yourself, why are there so many constructors, right? There shouldn't be so many. You should try and use getter and setter methods. That's the better way to do it, right? From an initialization perspective. And if you're going to use a constructor, only initialize, keep it as low as you can, because once you start increasing the amount of constructor methods, then you get confusion and it doesn't know what to do. And you might get the wrong answer, the wrong thing. It does and it doesn't in C#. It does, but remember, it'll try and choose the next, the closest converter, right? Especially if you put the wrong values. So imagine we just did this test, right? Imagine if 2 of the values are wrong, right? So I have like 4 parameters, but 2 of the values are wrong at the end. One of them is an int, and it's supposed to be going to a long or a double. Another one is a float, and there's only a double. What happens, right? Both can convert it, right? So you get different answers. The spaces change, right? So that's why I don't recommend. Try and keep your constructor signatures low, because remember, when you're using your constructors to initialize something. That's what you're using it for, to initialize variables, right? Typically. Okay, I'm not going to go too much into more of this constructor stuff. We talked about overloaded constructors ad nauseum. One thing I want to talk about, which is kind of a weird thing later on down the road, we talked about getter and setter methods, and that they're called accessors or mutators. We talked about that. We talked about composition, and how composition is when you call one class from another as a class object, like for example the idea of cards and decks, right? I'm not going to go too much into that. Now here's where we go enum types. Here's an enum class. I want you to look at this construct before the end, guys and girls, right? And by the way, am I ever going to test you on this kind of stuff? Chances are not, right? I'll tell you why. It's a construct. Is it something that's popular or that's wise to do all the time? No, it doesn't always work nicely. But in this particular case, where you have these book titles, this is a container, right? here I'm declaring an enum type book. Book, I can assign various properties. These are almost like constants, if you will. And if you notice, the convention is to make them all uppercase. So here it is. I have a constant, JHTP, which stands for Java How to Program, and there's a second value, 2015. Okay? That's interesting. So I have all these constants, right? And then I have a couple of instance variables that are private. One that's a title, and the other one that's a copyright year. But look what we have here. Here's my constant. Here's my title and my copyright year, right? How do I consume this stuff? How do I eat, this stuff up, right? Well, I have a constructor. Here's my constructor called book, same name as my the type, right? And what it does automatically is say this dot title is equal to title, and I get two things: title and copyright year. And I have a getter method, and for both the title and the copyright year, right? And this alone allows me to consume all these topics right here, and I can loop through these with a more enhanced for loop, the enhanced for loop that we saw before, right? As an example in the test. So here's our enhanced for loop. Remember we saw this almost like a for each, this structure right here. And this is called an enhanced for loop, right? So if I look through my book, my enum, which is just a structure, right? A bunch of constants. I'm looping through and I'm saying, take a look at the values. There's no index for these constants. This is where it's really good to use an enhanced for loop, right? Where a construct doesn't have an index like an array list, or some kind of other collection, right? And I want to go through and loop through, and I'm looking through each book value and I'm outputting them, right? The book values, where are they coming from? Well, they're coming from here, this. Once you do this, it's almost like you're declaring a bunch of data, right? This data type, this new data type you're making, this enum, can consume. That's what you're doing, right? So if you ever see this, this is an each construct. I'm going to tell you right now, I'm going to put up my hand and tell you right now, chances are, right, in your life as a software engineer, right, you probably won't use this structure very often, right? It's there. I think you might use enums when you want to use constants and you want to bind them to a certain common name, like the whole idea of Monday, Tuesday, Wednesday, Thursday. You want to check in on the calendar for what day it is. Enums is a good way of doing that. Using constants where you want to use a friendly name, right, instead of using some kind of number like 0, 1, 2, 3 in a switch statement. Enums is a good way to do that, enumerations. But other than that, you're not going to see that, and I'm not going to test you on it. The stuff that I covered already. Oh, one note, garbage collection. Is it really important for us to do garbage collection in Java, right? Just like in C# and in VB and other more higher level languages, garbage collection is automatic for the most part. You can still run into some problems when you program in, when you do mobile application programming, and that's where constructors and destructors are used, where we do manual garbage collection. Because garbage collection means, like, if you have a variable, the name that doesn't get destroyed, something that left hanging around, right, in the machine, you want to collect and you want to release the memory back into the greater machine memory, right? And that's the reason why we use garbage collection, right? Otherwise, it causes these resource leaks. When I launch a program, I eat the memory and I never return it back to the fold, kind of thing, right? If I launch that program a bunch of times, right, then I keep eating the memory until my machine crashes. Now, it's not so prevalent on a desktop, but on a mobile device, for Android as an example, we watch garbage collection very closely. So I'm talking about garbage collection, but I don't intend for you to learn about it or use it. Again, your life as a software engineer, unless you get really deep into it, probably won't need it, especially within your languages. Static class members we talked about with our main, how it's actually a, what ends up happening is it's a container class. We never have to instantiate them, right? Just like we never have to instantiate an object of class main, right? We can still use the object. So think about another static class like the math random class. Random, right, is a method that's part of the math class, right? And we're calling this method to generate a random number between 0 and whatever, right? or math.py or whatever. They're static members. We never have to instantiate them as objects, but we can still use them as part of the library. Okay. So those things we've kind of covered before, but they're in this PowerPoint. If you're interested in reading about it, they're pretty good. You can certainly do that. Take care. Probably not going to talk about too much else here as we wrap up. Here's one. When we talk about package access, you might hear package access. Again, not as common, very, very uncommon method. If you can't access a method directly, this is probably almost not used at all, this whole thing. And like it says here, package access is rarely used. It's one of those things that is part of the Java option. But what you can do instead is just, instead of using the package access, and when I say package, it's almost like namespace. I want to access the whole namespace. How often do we do that? Almost never. And that's why it's the same thing here for Java. We never use that. We can create a package data by connecting to the package itself, as opposed to linking to the namespace. One last thing, and then I'll let you guys go. So you want to do this banking application, right? And the banking application that you want to do needs double precision, right? There is an actual really cool class you can use that they've introduced. Again, math.bigdecimal is kind of this banking double, if you will, that does a very precise number of points, and it's very accurate when it comes to things like rounding and so on. So again, if you want to use math calculations for banking or for that kind of thing, or to calculate amortization and those kind of things, and be very accurate, we use big decimal. But again, it's so rare for the average person to use something like that. And typically when you work in an organization, they might give you some other construct that you would use. All right, so that's really it in a nutshell for this week. Okay, I've covered everything else that you need to know. And then next week, this is the more important week. You're going to get assignment number 3, and we're going to talk about a very important topic, inheritance and polymorphism. Okay? And that's it for me.